Hello everyone, in this video we will be solving a numerical in solid stepper bar. So this problem is very similar to the 1D bar problem what we discussed in the previous modules. We'll just have a look on the given question. So what is the question given is a solid stepper bar of circular cross section shown in sketch below is subjected to a torque of 1 kN meter at its free end and a torque of 3 kN meter at its change in cross section. So, a two torque is given. First is at its free end and second is at a change in cross section. So, we need to look at the sketch, then only we will come to know what is exactly the torque is given. Here you can able to see that. So, this is the a free end and this is the change of cross section. Even we are not sure where the torque value is given. So, what they ask us to find out from this problem is determine the angle of twist and shear stresses in the shaft. Unlike the bar problems, usually in the shaft problems we will be finding out the angle of twist and shear stresses. But the methodology what we followed for solving the bar problems remains same for solving even the shaft problems. And the material properties, Young's modulus given is 2 into 10 power 5 Newton per mm square and the rigidity modulus G equal to 7 into 10 power 4 Newton per mm square. So this is the given sketch. The stepper bar of circular cross section. The first part is having the diameter of 100 mm. The second part is having the diameter of 50 mm. First element length is 200 mm. The second element length is 400 mm. So we shall start the problem with the very first step, that is the finite element modeling. So here again I have shown here, you can able to see here the given question says that the free end a torque of 1 kN meter is applied. Similarly, at where the change is cross section of torque 3 kN meter is applied. So this is a given condition. So the finite element modeling, if you see, we will be going with as usual 1D element, which consists of 3 nodes, because from this end to this end there is no change of cross section. So I'll be going with first element, and similarly from here to here there is no change of cross section. So I'll be completely going with one full element here. So totally of 2 elements, of element 1 having nodes 1 and 2 and element 2 is having nodes 2 and 3. And instead of here U1 or Q1, here we will be having a torque and the angle of slope. So that I'll be mentioning as T1 theta 1, T2 theta 2 and T3 theta 3. And in the question there is a data given, that is the Young's modulus data. Here I have written this as a note. Young's modulus data is given only for the material identification. Sometimes what happens, both the materials can be made with the different properties. Such times we will be we can easily identify how to find out. We will move to the step 2, which is nothing but the element stiffness matrix. So what is the formula I will be using to find out the element stiffness matrix is Gj by L 1 minus 1 minus 1 1, which was already discussed in the previous videos. Just have a look on the element stiffness matrix derivation for a shaft material. So for the element 1, which can be written as K1 equal to G1 J1 by L1, since both the material is having same material properties, G1 and G2 remain same. And here what is the one thing which will be changing is nothing but J, which is nothing but the polar moment of inertia. For the circular cross section, the formula given is pi d power 4 by 32. Since we will be talking about the shaft, so we can fix it up for most of the problems. The cross section will be circle. So further the polar moment of inertia formula will be pi d power 4 by 32. So I'll be substituting the first element diameter, which is given 100 mm. So it is pi 100 power 4 divided by 32. After simplification, I'll be getting it is 9.81747 into 10 power 6. So I'll be substituting G1, J1, and before substituting, I made sure that all the data I'll be substituting in the same unit. So what is the unit I'll be following here is it's millimeter, and Newton. Everywhere I'll be following the same thing. So G1, J1 and L1 of matrix 1 minus 1 minus 1 1. So after simplification I'll be getting 10 power 9 of 3.4361 minus 3.4361 minus 3.4361 plus 3.4361 for the element 1. For the element 2 I'll be following the same thing with the change of formula K2 equal to G2 J2 by L2 1 minus 1 minus 1 1. So J2 it is pi by 32 d 2 power 4. So I know the D2 value, which is given as 50 mm. After substituting, I will be getting J2 value as 0.613592 into 10 power 6. So I will be substituting G2 J2 divided by L2, and the result of the simplification gives me 10 power 9 into 0.1073 minus 0.1073 minus 0.1073 0.1073 plus of the node numbers 2323 for the element 2. The next step is global stiffness matrix, where I'll be assembling all the element stiffness matrix. So first I'll be writing, looking at my modeling. It is having 3 nodes. Since each node is having 2 degrees of freedom, so the order should be 3 into 1. Sorry, it is 1 degrees of freedom, so order should be 3 into 1. It is 3 cross 3. So here also I'll be going with the same thing. So 1 2 3 1 2 3 I'll be writing. I know like how to add up the location, that is 1 1 1 2 and 1 3. The same way I'll be following for solving all the problems. Next is step 4, where I'll be writing the displacement vector and the torsional vector. In case of the bar problem, we used to follow the same thing. Here also I'll be following. Here instead of the Q, I'll be going with theta, because there is angle of twist here. So theta 1, theta 2, theta 3 I'll be having. Next is torque. Instead of the force, here I'll be writing as the torque, that is T1, T2, T3. So as usual, whatever the value is given, that I'll be writing. Since they have not mentioned the angle of rotation, that is clockwise or counterclockwise, until or unless they have not mentioned, always go with the positive values. So T1 value is not given, so it is 0. T2 and T3 has given us 3 into 10 power 6 and 1 into 10 power 6 respectively. So the next is the equilibrium condition, which says that global stiffness matrix into the slope vector, which is equal to torque vector. I know the K value, I know the theta value, even I know the T value. The boundary condition, which for this I will be following the same the elimination approach method which I followed even for the bar problem, the truss problem. Since the node 1 is fixed, I will be eliminating the first row and the first column in the equilibrium condition. You can able to see here the first row and even the first column, even in the slope vector and even the torque vector, both the things I will be eliminating. After eliminating, I will be getting a 2 cross 2 matrix of theta 2, theta 3 vector, the slope. So I will be finding out the unknowns. So I will be getting theta 2 and theta 3, and since all the substitutions and the data transformation I have done in the beginning steps itself, the value of theta 2 and theta 3 I will be getting in the units of radians. So you should not forget to write the units for theta 2 and theta 3. And in case some examiners expect the theta 2 and theta 3 in terms of the degrees, just do the conversion pi by 180. Next step is the elemental shear stresses, which is asked in the question. What is the formula I will be following? So the shear stress I will be denoting as a tau, and since for the element wise I will be finding out for the first element I will be writing as a tau 1. The formula says is GR by L minus 1 theta 1 theta 2. For the element 1 it is G1 R1 by L1 minus 1 theta 1 theta 2. For the element it is node numbers 1 and 2. I will be substituting G1 and R1. R1 is nothing but the radius for the element 1. Since the diameter is given, half of the diameter will be considered as the radius. So whatever the values are there for thetas, the same thing I will be substituting, and from this I will be finding out the shear stresses. Similarly for the element 2, the formula is G2 R2 by L2. So minus 1 theta 2 theta 3. For the element 2, the node number is 2 and 3. So I will be substituting even these values and I will be finding out tau 2. So this is how the problem should be solved. In case if you get any doubt to solve this particular problem, post your doubts in the comment sections. Thank you.